Hey everyone, thank you for coming to DDD 2020 and for coming to my dependency injection talk. For those just joining us, just a reminder that we're operating a code of conduct, which in summary is basically be excellent to each other. If there's any behaviour that makes you feel uncomfortable, please make the producer aware of it in the chat window. This year, we're asking you to show your appreciation by making a donation to the National Museum of Computing based in Bletchley Park. This is a brilliant cause, and I, for one, am looking forward to going to see it when things go back to the so-called normal. Next, a few thank yous need to be made. Firstly, thank you to Microsoft for sponsoring some giveaways today. So look out for those if you went through the registration process. To Plaque Marble, who have done a brilliant job of organising today in such a short space of time. Big thank you to all the volunteers behind the scenes, without whom I'd be speaking to a blank wall and you'd just be looking into a black space in vortex on your screen. Last but no means least, thank you to IO Associates, Grey Matter, and last of all, NDC London, where I'll be speaking next month. Please spread the word on social media by including the hashtag DDD2020 and mention at Developer Day. So without further ado, let's start talking a bit about dependency injection. So for those of you who don't know me, I'm Steve Collins. I've been a programmer in one form or another since the early 80s, but professionally I've been doing this since the early 90s, starting with VB3 and then moving through to .NET when that came out. I can be found at Steve Talks Code on Twitter, and also I blog at stevetalkscode.co.uk. So with that all done, let's get started. As I've got a lot I've got to try and pack into in the next 45 minutes or so, I've had to make a few assumptions about what you may or may not already know about dependency injection in .NET Core. First is that most of you will be familiar with using a host builder as one flavour or another to create the container. But you can also do this manually, but I'm not going to focus too much on that today. The next is that you're used to using a startup class, which you tell the host builder to use, and in that class, you register your services with configure services method. Generally, there are various types of dependency injection styles, which I'll come on to in a minute. But for now, you'll just need to be aware that out of the box, the only type that is supported by the .NET container is constructor injection. And in most cases, if you want to look beyond that, you'll have to go to other containers. Having said that, if you're working with ASP.NET Core, you can make use of the method parameter injection by using the from services attribute on the parameters that you want injected from the container. This helps with minimizing the number of parameters that you have to pass into your controller and is more aligned with the single responsibility pattern. A few others that aren't supported include property injection, where the dependencies aren't included in the constructor, so you have to set them after the instance has been created. Named or key valued injection, where you ask for a dependency using a string or some kind of value like an enum. And lastly, automated service registration by convention, which is a bit of a mouthful, but in short, it means that the container scans an assembly and pulls out classes and interfaces to register based on a set of rules that you specify. The good news is that I'll be showing some workarounds today that will help you implement these without having to rely on another container. But why are those other styles of injection not supported? Well, the Microsoft container is what's known as a conforming container, which is a fancy way of saying that it only supports the lowest common denominator of functionality. But it can also act as an abstraction over other containers as well via the common interface. There's a number of other container frameworks out there that I've listed here. The ones that Microsoft put on the docs website have been adapted or extended to work with the iService provider interface. The downside is that if you want to use functionality that's not part of the Microsoft container, you use one of these, you have to manage both containers side by side, and then need to know how and who is resolving your dependencies. If you're using Core 2 and would like to wire up one of these containers, these implementations usually give you an extension method that you can then use to generate a service provider. You would then use that extension method to return the provider from the configure services startup in the configure services method, in the startup class. But all this changed with Core 3, and I'll talk about that shortly. So moving on, let's look at your typical service registrations. In this snippet of code here, we have the registrations that you're most likely to be familiar with. They've got different lifetimes, and I'll come on to those in a minute. As we've already covered, the host builder will call the build service provider method to create the container instance based on the service registration. But once built, the container is then used to resolve the instances of services whenever they are required. Now, on the previous slide, I said that when moving from Core 2 to Core 3, or .NET 5 as it is now, we're no longer required to return the service provider. In fact, it's now actively discouraged. If you try and return the service provider from the configure services method, you'll get a Roslyn analyzer warning. The reason for this is that since Core 3, the way the service provider is created by the host builder has changed. What this also means is that whilst in Core 2, there was a small performance gain to be taken by implementing the iStartup interface when using the web host builder, this is no longer supported in the generic host model. If you want to use an alternative container, there is the use service provider factory extension method that you can use on the host builder to expose an alternate container via the Microsoft abstraction. Once that will register a custom container, you still need to configure that container with the configure container method. You can either do that directly off the host with an extension method or within your startup class. And that's where you'll receive the native container from the service provider that has been built. As the configuration differs from container to container, I won't go into more detail here, but there are definitely examples on the AutoFac and Lamar documentation pages of how to wire it all up. So having covered how the container gets built, let's go back and give some consideration to the instance lifetimes that you may want to create for you. Now, I'm sure that this is familiar territory, but I've included it to make sure that everyone is at the same level of understanding before we delve in deeper. Firstly, we have singletons, and these are created once only and live for the duration of the container. Then we have transients, which are our fair weather friends and come and goers and when needed. Last but not least, we've got the scoped instances, and these sit between the two, which I'll cover in more detail. The thing to consider with these different lifetimes is that some of them play well with each other and some really don't get on. So let's break down those differences. Starting with the shortest lived of the lifetimes, the transient can accept objects of all the three lifetimes. Moving up through the lifetimes, we then have the scope lifetime, which because it's lived slightly longer lived, it shouldn't really have the transient lifetime injected into it. Lastly, we've got the singleton, and this is the longest lived at all. And really, that should only have other singletons injected into it. Now, I've tried to choose my words carefully here when I've said should, because there's a general misconception that you can't inject incompatible lifetimes into each other, but that's not strictly true. I can't speak for other containers, but the Microsoft container won't actually stop you. If you have a singleton and its constructor requires an instance of something that's been registered with a shorter lifetime, the container will happily give you that instance. The problem is the instance that you get will have a lifetime promoted up to that of the receiving instance. In other words, a transient instance will be locked into a singleton and not released until that singleton is disposed of. And that doesn't happen until the container is done and dusted. This is known as a captured dependency, and where the transient or the scoped instance is like the insect in amber I've got shown here. It's imprisoned in that outer shell, which in our case is the singleton. But you may be wanting to hit the pause button and go, hang on, when I've done this, I've got an exception. Yep, that can occur. By default, it only really happens if you've got your ASP.NET Core environment variable set to development. This is because there's some hidden magic that lies in the host builder. However, you can explicitly turn this behavior on by setting the optional validate scopes parameter to true when you create your service provider. Trouble with this is that there's a performance hit because it's having to work out all the dependencies and whether they're compatible or not. So general guidance from Microsoft is not to do this in a production environment. So what are the typical candidates for singletons? Well, ideally singletons should be stateless, and therefore you can avoid threading complications. Sometimes you may well have to have some sort of state that you need to share though. This might be a pooled resource, an in-memory queue, something where you need to be in control of a limited resource that multiple things are dependent upon. Factory and builder classes I'll talk about later, but typically these are created once and their methods are used to call to create shorter lived instances of some other dependency. You may be aware of ambient singletons, which hide the complexity of accessing shorter lived objects, something like the HTTP content accessor in ASP.NET Core. And that uses async local storage to avoid capture dependency problems, but it does get a bit complicated. The last of these cases shown here is the immutable state. This is where you don't want to have to go and recreate a resource object over and over again when you know that the data will not change for the lifetime of the application, or at least the container. For example, lookup data that you may only read once from a slow repository, for example, database, file, network service. If you really must have state, give some thought to letting .NET do some of the heavy lifting for you. If you have collections inside your singleton, maybe consider using the concurrent collection namespace, where the thread safety stuff's already been done for you. For read-only properties, make sure that the underlying field is read-only, so that when someone comes along and tries to make it read-write later, at least they have to do some work and think about what they're doing. For those properties that do need to be read-write, maybe you should consider using a thread lock. So in this slide, we can see that we're ensuring all property access is managed through a thread lock. That way, we can ensure that the value is only changed by only one thread at any one time. The problem with this approach is that by serializing the access into the property, you'll get a major performance hit that you're forcing everything that touches it into a sort of narrow stream one by one. If you do that, then maybe you should consider your design or maybe looking at async local. I don't have a panacea for this. I'm just warning that this may be a code smell. Lastly, you may want to consider the impact of having disposables in a singleton. The problem here is that if you expose dispose methods and the consumer calls it, the object is gone for everyone else. However, you do still need to make sure that the dispose method is there for the container to clean up after itself when it's done with the resource. To get around this, consider abstracting the class with an interface that exposes the members except for the dispose method. That way, when the instance is served up from the container, there's no way for the consumer to be able to call dispose because it can't see the do not dispose me. All it can see is the do something. For transients, there's not really a lot to say other than just be careful about doing a lot of work in the constructor. As you don't have control of when these instances are created by the container, and there could be lots and lots of them, especially on a web server, that may have a major hit on your application performance if they're doing something like going and getting data each time they're instantiated. Moving on to scope lifetimes, these need to be handled with care. We've already covered interacting with other lifetimes, but what exactly is a scope lifetime? The common answer is that they're created by ASP.NET Core middleware for HTTP request response lifetimes, but that's not the whole story. A scope is not tied to just HTTP lifetimes. You can go and create them yourself, especially in things like console applications. A scope is really there to ensure consistency within a unit of work. So when you have several objects that all rely on one object within that same scope, they all get the same instance. So acting a little bit like a singleton, but within a boundary. However, once you go outside that boundary, you get a different object. So in that way, they're a bit like a transient. You can manually create a scope yourself by calling the create scope method on the service provider instance. This gives you back another iService scope, which is a single property of service property, which is an instance of iService provider. All gets a bit meta, and you need to look at the methods because it starts to get a bit complicated trying to just explain it over a conference. As I say, in ASP.NET Core, the creation of scopes is taken care of for you when the request response lifetime is started. That scope container is carried through all the way the pipeline by the HTTP context request service property. Behind the scenes, the call to create scope is handled inside the request services feature class. So here we see a create scope being called and the request services property returning a scope provider. Excuse me. A lot of this is all hidden away and you don't really need to care about it. The main thing you do need to be aware of is whether the things you're asking for in your constructors are likely to be scoped or transient or singletons. However, there is one area of ASP.NET Core that you do need to be aware of what's going on under hood if you go and write them, and that's middleware. Now, when we talk about middleware, we generally think about handling HTTP requests and responses. Now, you might be assuming that because that's kind of scoped, that there's some kind of scoping registration going on, but that's not the case at all. When you register middleware, it is done on the configure method of the startup class. Now, at this point, we talked about configure services just now, where you go and set up your container. But with your configure, the container's already been baked and you get a copy of the service provider in through the app parameter. What you're not doing is adding middleware to the container. That's all done. Instead, what you're doing is inserting a delegate into the invoke async method that's on your middleware. And that's all done as part of the pipeline work. In order to do that, it creates a single instance of the middleware class. Now, when that single instance is created, any dependencies are resolved from the container. And therefore, if you request a dependency that's registered as scoped or transient into the constructor, we're back into the territory of captured dependencies. You also need to bear in mind that the pipeline is created before the first HTTP request, so you won't be able to access anything that relates to the HTTP context in the constructor, as it doesn't exist at that point. What you'll get is an invalid operation exception thrown because it cannot be resolved at the point that the class is being instantiated to create the pipeline, because you've got to have a pipeline in order to have an HTTP context, and this is part of creating the pipeline. Other scope dependencies are not part of the pipeline. They may resolve, but like I said earlier, they become a captured dependency. So how does a request, so HTTP request, which we said it sort of has a scope to it, how does that get dealt with? Well, as the request moves through each layer of the middleware in the pipeline, the invoke method gets called via reflection. So it's not using some interface or abstract contract, it's just reflection based on the parameters you've specified in the invoke method. To do this, when the middleware is added to the pipeline, the request delegate is created. The delegate acts as a wrapper over the invoke method. As you can see here, the request delegate is passed as a parameter into the middleware constructor to enable the request to be passed down to the next one in the pipeline, and it goes down and down and down and down. You're free to add scope dependencies as parameters to your invoke method if you need to do some work before and after the next thing in the chain. So as I say, whilst you can't use scopes and transients in the constructor, the invoke, because that's part of the pipeline and you've got HTTP context that has created a scope, you can have your scope dependencies there. I touched on disposables earlier, but to bring it all together, there's a few things to mention here. First, I said about hiding the dispose method as the container will take care of it. Now that's true in most cases, certainly for transients and scoped, but for singletons, it's slightly different. What you need to do is be very careful about anything that where you create the instance yourself and then expose it through some kind of factory or directly in the registration. So as you can see here in this slide from the docs site, there's a couple of extension methods here which allow you to go and create singletons by newing things up yourself. But as highlighted, the container won't dispose of these for you. If you do create a disposable class in this way, the problem is that there's no obvious re-entry point to configure services on the startup class for you to go and dispose them, so they're sort of stuck there. Why would you take that approach? Well, reason may be that the object you've got, it needs some parameters that you can't resolve from a container, so therefore you've got to new it up yourself and pass something in. If that is the case, maybe you should consider using a factory, which I'll come on to in a bit. But if you really must do this, there are some get out of jail cards that you can use. There's an interface that is automatically registered by the host called iHost Application Lifetime. This can be injected into the configure method by adding it to the parameter list. Here you can register a handler for the application shutdown, which is past the object that you want to dispose of. That's fine if you've just got one object, but it does get messy if you've got lots of them. And you may want to consider putting them all together into one kind of composite singleton, which has a dispose method, and that takes care of disposing those sub-dependencies. Coming back to the dispose method, if the class is not yours and it doesn't have an abstraction that hides the dispose, you may want to consider other gang of four patterns such as facade, adapter, bridge, or proxy. These are all variations of a theme where you create some kind of wrapper class to handle the creation and disposal of the class instance. The last point is a rare one and a code smell. But if you have a class that has a control freak and insists on disposing the instances passed to it, then instead of getting the container to create those instances, maybe create a factory and pass the factory in and use the patterns I've mentioned before. So with all that foundational stuff, let's move on to avoiding some of the gotchas that can trip you up when registering or consuming services with a container. What happens when the same service gets registered multiple times against multiple implementations? You may well be doing this deliberately because you want to have several implementations that you want to iterate through, such as something like maybe validation rules. But it can happen by accident. For example, you may have a Git merge that's gone wrong and no one spotted that you've got the same registration going in there twice. Sometimes you've got extension methods registering different implementations to the one you are registering. Whatever the reason, there can be unintended consequences because of the way that the container works. Namely, it works on a last in wins principle. So if you call an extension method after your registration, and the extension method's implementation will be one that will be resolved by the container, you need to give some thought to the order in which you set up the dependencies in configure services. Now, of course, if you're writing an extension method, the onus is on you to play nicely because you're publishing it to a wider audience and you don't know how people are going to use your package. As we know, there needs to be care around lifetimes and things that get messy when there's multiple registrations with different lifetimes. So you may think you've registered a singleton as a consumer, and then you've used a NuGet package, and someone comes along and trumps it with a transient or scoped, and then things maybe start to go wrong if what you've assumed is your singleton gets injected into a singleton, and you get transient or scope that's a captured lifetime. Now, maybe that, as I mentioned on the previous slide, you deliberately want multiple implementations, and I'll come on to that in a minute. But getting back to avoiding accidentally registering multiple times, there are two ways out of the box to get around this. The first is to use the try-add methods, where the first registration is kept and subsequent registrations are ignored. So we flip from last in wins to first in wins. If one's already there, it won't go and do another registration. The second are the try-add enumerables, which are a variation of a similar theme, but this time it not only takes account the service or the interface, but it also looks at the implementation as well. So if you try and implement multiple times with the same implementation, it'll ignore them. So in this example here, where we've got the triads in the first example, the first entry wins, so Earth will go in and it'll ignore the other 5. In the second entry, where we've got triad enumerable, the first entry per service and implementation wins. So you get Earth, Mars and Jupiter, but not the second 3 where it's duplicated it. So that's the gotchas done. Now let's look at some helpful hints and tricks. Flipping what I've just said on its head, and as I say, there may be some occasions where you really do want to deliberately multiple implementations that the caller needs to iterate over. Something like validation rules, or I can't think of another example off the top of my head. However, the consuming class needs to know that there will be multiple registrations, because if it just asks for, in this case, iBackpack, if it's just been done with a regular registration, it'll get the first one. And if it's done with the triads, then it'll get the last one. So having that knowledge is, there's an implication that your consumer needs to know that. And the way they do that is by asking for an IEnumerable of your service. If the order of the enumerable is important, there needs to be some way of differentiating each instance. Without that, the consumer will have to rely on the order that the registrations were performed. Now, there's lots of ways that you can handle that. You could create a comparer that implements iComparable, and therefore, if they use the link, then the iComparer will sort them for you. You could create a dedicated class and register that so that they don't ask for the IEnumerable of backpack. They ask for something like list of backpack or something like that. Lastly, you could register a Lambda expression and do it all within the startup, but that feels a little bit clunky. So now let's take it the other way around. What you could do is you may have a single class that's got multiple interfaces, especially if you've gone down the interface segregation principle from the solid principles. If you register a type with each interface individually, then what will happen is you'll get a separate instance for each call. What you really want to do, is, especially if you've got scoped or singletons, is you just want that one instance to come back with through its various different interfaces. The way you do this is by just registering the class or an aggregate of the interfaces up front, and then using the get required services to pull out that instance out of your container and then serve it up through the different interfaces. In some cases, you may want to aggregate them all together, though. So as we've got here, I've got the IMyInterface aggregate that does interface 1, 2, and 3. So that way, even if the class that implements all those interfaces doesn't have some kind of aggregating other than the class itself, you can proxy it with this other interface effectively. Next, we have open generics, where you define a type parameter on a class such as list of T. Now, the place you'll most probably be familiar with this when using dependency injection is the iLogger T interface. If you're using ASP.NET, quite often you'll inject your loggers into your container. Sorry, not your container, your controller, for example, and you'll say iLogger my controller. Similarly, you may be familiar with the iOptions interface that Kev mentioned in his configuration talk this morning, where you use the configure method to bind a configuration to objects. So as Kev covered that, I won't go into details now. If you want to register your own generic types, the C# syntax doesn't lend itself to referencing open generics with a generic. It all gets a bit meta. So instead, what you have to do is use the non-generic registration methods, where you can then say a type of keyword to get the class without giving the type parameter. In the case shown here, iList and list are shown with the angle brackets, but no type parameter, as they will be supplied by the consumer. Behind the scenes, the container will make use of the type make generic type method to go and create a closed type using that type T. So for example, you might have a list of strings. Now in the real world, you wouldn't be using the likes of lists or dictionaries, but you may have some helper classes that you've created which do have this sort of open generic style to them. At the moment though, if you go and put a generic constraint on there, it will throw an exception. Now, what happens in .NET 5 is that Jimmy Bogard did a pull request that added a try catch that allows constraint generics to be resolved, and that was the problem. But it took 4 years for his pull request to get accepted into the main BCL. Now, if you go and read Jimmy's blog, you'll get to understand why there's been very little change in the Microsoft container pretty much since its inception in Core 1. In short, if you need to make a change and submit a pull request, you have to ensure that all the other container technologies that I mentioned that also use the iService provider won't break, which in turn means you have to write unit tests, not just to show that your change either fixes something or adds something new to the container experience, but that it doesn't break those containers and anything in the future that may rely on iService provider and what you're doing inside the container. Next, I want to talk about a couple of old school patterns that are very relevant in the DI container world. The first, and I've alluded to several times throughout this talk, is the factory pattern. Now you may be thinking, Steve, surely the whole point of a container is the factory. Why would I need another factory class? Well, sometimes you need to give the DI container a bit of a helping hand. For example, some of the constructor parameters for a class may not be known at runtime, as they may be captured from user input. You may have something that you've got name and address coming in and you want to inject those in, so you can't do that directly from the container. Alternatively, it may be that the instance that gets created is a bit of a resource hog and you need to dispose of it pretty quickly, but you can't necessarily guarantee when the container is going to do it, depending on whether it's transient, scoped or singleton. So what you may want to do is have something that's very short-lived and use a factory to serve that up and pass it, and then it's up to the caller to remember to use the using construct or dispose to get rid of it once it's finished with it. Lastly, at the start of the talk, I mentioned that Microsoft Container doesn't support property injection, but by using the factory method can effectively simulate property injection because it can get the container to instantiate the underlying class that you need to set the properties on, and then your factory can go and set the properties for you and then just return you that completed object. That's where factory really sort of comes into its own. Usually you'll want to register the factory as a singleton, as most of the time you'll just be it will have other singletons coming into it. If you need transients, it's worth taking the service provider itself as a constructor parameter, but proceed with caution. Direct use of the iService provider is generally seen as a service locator anti-pattern. So it used to be a pattern and now it's considered sort of bad form. You shouldn't be doing it. The reason that it's an anti-pattern is also it's tight coupling to a particular container technology. So for example, by passing in iService provider, you're pretty much locking yourself to that Microsoft interface. Really, if you've got classes that are sort of spread across things, maybe you want to use them in Xamarin or something like that. You don't necessarily want to tie yourself to those interfaces and having to rely on certain other assemblies. My personal view is that factory pattern falls into a class I refer to as servicing classes. These are plug-in gaps in the container functionality and effectively an extension to the container. So with that in mind, I'm sort of fairly relaxed about it and being pragmatic over dogmatic. But if you're worried about the factory classes exposing this anti-pattern and having tight coupling, what you can do is you can create an interface and make your factory class private inside the startup, so that you're putting it within the boundary of the container and it doesn't leak outside the container, other than the interface that just has one method which says create or build or something like that. A variation of the factory pattern is the builder pattern, whereby rather than prescribing which dependencies are needed up front and creating the instance immediately, the builder is much more a layered approach. The way I like to think of it is like I've got in here. If you go to a fast food restaurant, some of them have got a fixed dispenser like you've got on the left. So you ask a person for a cola and you're very limited to the specific types of cola that thing can create. With the builder, it's more like the more modern ones you've got on the right here, where you've got a base thing, the cola, but then you can add a dash of lime, a dash of vanilla, a bit of cherry as well, gradually composing it up bit by bit until you've got the customized version that you want. Now, what that example was a bit contrived, and if you've got cola, lime, cherry, and vanilla, that sounds pretty awful to me, but you get the idea. So with the builder, we start off very much like a factory, registering it with the container, usually as a singleton. As constructor, we can take in other singletons or the iService provider, like I just said, to try and get transients. But then consuming classes, we'll take the builder as a constructor parameter and then start adding to properties and methods on the builder until it's at the point where you can say build. Now, you're probably familiar with this from within the DI container itself, the host builder, not the container, the host builder, because that is a builder pattern. Like the factory, if the instance you're creating is disposable, the caller will be responsible for disposing the object that you've just created. Now, so far, we've kind of assumed that the factory or builder will be using the new keyword inside. But wouldn't it be better if we could take advantage of the container to do some of the work for us? But there are some problems, like how do we populate missing parameters? How do we get those parameters from the container, so the singletons, the transients, the scopes that we know are already registered? And then how do we munge them in with the stuff that's just coming at runtime, so name and address, maybe something like that? You could use the iService provider, but I just said that's a bit of an anti-pattern, but that's where maybe the activator utilities class can come in handy. What it does is it takes in an instance of the iService provider, which you can get injected into your factory, but then what it can do is it can take an array of objects. It then does the work of matching a known constructor in the container to what has been supplied, filling in any missing parameters with instances from the container. This can be useful when some of the parameters of the new instance are transients, so it shouldn't be passed via the singleton constructor. Sometimes it may need some help. You may need to add a helper attribute onto your classes. But if you're designing your classes from the bottom up, rather than relying on externally developed classes, you can design your constructions in such a way to avoid this need. Now, downside to using this is that you may take a performance hit because it's having to use reflection to work out what it needs to do to build your objects. So in some cases, this may be where you bend rules and just say, you know what, I'll just use the iService provider and I'll munge it all myself with a new. Another place where factories or builders can be useful is if you need to get a value type from the container. Now, the reason that you may want to do this is you simply cannot register a value type with the DI container as it's not supported. Here you can see an attempt to add the registration using the generic add transient, and there's an analysis error straight away. You may think, that's something to do with using the generics. But if you try the non-generic version, then all you're doing is you're kicking the problem down the road to become a runtime error. So how do you get around this? We simply create a factory or builder that takes the parameters. Now, the example here is rather contrived and offers no benefit over just newing up the object in your own code, but I'm just trying to show the principles here. What you can do is take some of the properties from the container, and this is where the factory can grab them from the constructor and then put them together with the method parameters. Which kind of leads us on to the new C#9 record types that Stuart was talking about first thing this morning. Now, because he gave that a rather in-depth view, I won't go into details here. But essentially, records are like value types, but they're actually reference types. And as they're reference types, you can register them with the container. However, given that record types are really predominantly used for entities, you're more likely to use a factory pattern for the same reasons that I've given in the previous slides. If you're interested in finding out more, then I did do a blog on this. But if you want to go into the in-depth of C#9, go back and watch Stuart's talk from this morning when it's available on YouTube. Or there's the on.net show video that I've got a link to here, which was where I really got my head around records. Next, we have something that no one really talks about with DI. We nearly always talk about classes and interfaces being registered with the container, but delegates are also a first-class citizen and can also be registered. Now, in theory, you can register an anonymous delegate using the funct and the variations of funct. Problem with that is because they're very generic, it's very hard to distinguish them for the functionality that you're trying to do. So to get around that, we can go old school and go back to .NET 1.0, Framework 1.0, and go and create custom delegates. Excuse me. Now, I go into details on my blog, but as a quick example, I really hate system date time. Main reason is that you just can't unit test it because its very nature is it's not deterministic. It's real time. You can't say, I'm expecting it to give me this time. But by creating a delegate, you are creating an abstraction without all the ceremony of having to go and create an interface that says go and get time, and then creating a class implementation that then reps that dreadful static property. This makes your registration code much cleaner as you don't need all that plumbing, and it's a bit less code you have to write. It also feeds into the single responsibility principle of the delegate just doing one thing. I will go and get you the current date time. If you want multiple date time related functions, well, yes, you could go create an interface with multiples in the class, or you could just register multiple delegates as long as their signatures are just slightly different. From a unit testing point of view, it's very easy to mock and create your own implementation because all you're doing is creating an implementation of that delegate. And with the date time example, you could have a fixed date time in your implementation that you can then use in your assert statements to say, I passed this date time in and I'm expecting it to do some manipulation of this date time and get this thing out. So that's enough about design patterns. What about those features that aren't supported in the conforming container that I promised you about? A feature that is supported by other containers, such as Autofag, is being able to request a particular instance just based on a string name or key. Now, it's considered a bit of an anti-pattern, a bit like using the service locator, because it comes back to the idea that your application code shouldn't need to know about the container's mechanics. But what if you could do it with your class having absolutely no knowledge of the container that's in use? So this occurred to me last year when I had a situation where the type of data mapper class I needed would be determined by a value that had been pulled from a database. So rather than writing a massive hard-coded switch statement inside my repository, I thought it'd be nice to get it just injected rather than having to keep updating that repository all the time, because then all I could do is I could just swap in implementations through my container. Now, it's a bit long-winded to describe here, so there's a link to my blog post, but to give you an idea of what's involved, I've got an example. So here we create a common interface with some classes, and all we're doing is we're just converting temperatures between sort of different scales into kelvins. So what we do is we register them all with the container as their actual types. Then right in that last one, we've got the Kelvin converter mapper, and that's a delegate that I've got at the very top, where you pass in a string and you're getting an instance of some Kelvin mapper come back to you. Now, for simplicity of this example, and I wouldn't really do this in a real world, but I've just used a simple switch statement that just uses a character lookup in case statements to determine which of the implementations you want. You're more likely to use some kind of dictionary or have some lookup table to do that rather than hard-coded cases, so you can encapsulate that and just make a simple one-line change somewhere else. Whichever way you choose to do it, the delegate is the secret source. This is what the consumer will use to pass in the string and get back the correct mapper instance that it wants. So now we've got a consumer class, get temperatures. The returns the degrees of whichever's, well, it's going to be kelvins, isn't it? Sorry. So all we're doing is we're injecting that delegate that just says, I want to get a mapper based on a scale. Our close has absolutely no knowledge of iService provider or how to get the different implementations. It just knows that by using that delegate, when we go and pass in the scale, and then we can go and get the temperature, we can get the mapper and convert it to kelvins. The decorator is another gang of four pattern that can be used to extend the functionality of a class by wrapping it and then re-implementing all the members, but where necessary, intercepting the incoming parameters and outgoing results to do something else. Now, the common example where you use decorators is usually to add some kind of logging, where you've got some third-party class that you can't change the source code, but you want to say, I want to log when it comes in and I want to log when it goes out. To do this, we still need the original class, but then what we do is we have another decorating class and we inject the original class into it. So in this example, we've got a class called DoSomething that implements the IDoSomething interface. First, we register the class as a concrete type and not through its interface. And then we have a decorating class called LoggingDoSomething that takes the registered original class and also requests an instance of iLogger. It then re-implements the getHello message method, but this time the code intercepts the input and output and writes these out to a log. One of the features of other DI containers is registration of services by convention or assembly scanning. Now, I'm not personally a big fan of doing this, as I'm a bit of a control freak and I like to know exactly what's going on for the reasons I said earlier about extension methods, for example. For that reason, as we saw earlier, it's possible to stamp all over each other's dependencies and get the wrong thing. However, if you've got masses and masses of classes that need to be registered, this can be a laborious process, and I totally get why you might be looking for some kind of shortcut. There's several offerings out there, but probably the most well-known is Scrutor, where you can define rules for criteria for registering classes and interfaces. One nice thing that I do like in Scrutor is the ability to register decorating classes with a much simpler syntax than the hand crank version I showed just now. So coming back to sort of patterns and solid principles, when I gave an early incarnation of this talk much earlier in the year, one of the people attending pointed me to a blog post called Nicola's Laws of DI, and there's a link here. In short, these are some of the basic things to consider. The first is not to create entities from the container, only services. Now, I think there are some exceptions to that, like I gave the example about cached stuff and what have you. But as a general rule of thumb, you'd be using some kind of repository patterns or factories to go and create your entities, not just registering them directly in the DI container. The rest of them listed here are more to do with solid principles. So I'm sort of getting a bit short on time, so I won't go through them now. I highly recommend going and looking at that blog post. The last topic I want to give a brief mention to is about performance. So some of your registered classes may take a while to be instantiated. Now, I gave a warning about transients, but certainly your scoped and singleton ones might have a little bit of background work going on. Now, if that is the case, certainly on ASP.NET, the first request coming in is going to take all the hit of all the JIT compilation and firing these things up and creating them and so on. So what you may want to do is, if you're using something like ASP.NET, is to have some kind of background service that goes and warms these all up for you. Now, because I've only got a couple of minutes left, I won't go into the details, but Andrew Locke has got a really good blog post about it, and I've got the link here, so it's well worth going and have a look. So with 45 minutes almost up, that just about wraps it up for me. Thank you for coming to my talk. I hope I've provided some value, even if it's only just one or two golden nuggets and gone, I didn't know that you could do that with DI. If you want to hear any more of my ramblings, I'm on Twitter quite a bit. I do have a blog, which I've been a bit lax about, but I'm starting to get more in the swing of writing, so look out for more in 2021. A few more honourable mentions. In that last slide, I mentioned Andrew Locke, who's got a brilliant blog and covers all sorts of things to do with .NET Core and ASP.NET Core. He's got the ASP.NET Core in Action book, and he's currently in the process of writing the second edition. So keep a lookout on the Manning side, because there's often deals to get the early edition half price or various discounts. The Microsoft Docs pages are well worth a look, especially if you're migrating from Core 2 to Core 3. And last but no means least, Mark Siemens' blogs and his books are well worth looking at to get a bigger picture of DI patterns and ANSI patterns in general, not just the Microsoft ones. And at 44 minutes and a few seconds, that's me done. Nigel, are there any questions?
Yes, there are a few questions.
Okay.
Would you like me to read them out?
I'm just trying to bring it up now. So what? Firstly, Dorothy, what do you know about registering HTTP Client Factory in the services, please? That is almost a whole talk in itself. What I would suggest on that is if you go and search for Steve J. Gordon, he's a real expert on the HTTP Client Factory. He's done a whole load of blog posts about that. So I can't really encapsulate that in a two-minute answer. So highly recommend going and looking at Steve's blogs, where he's got about 4 or 5 posts about it. For multiple registrations for same interface, could you use Scruter? I can't remember off the top of my head whether you can or can't. I think what happens is that Scruter, based on some rules, if you've got classes that implement multiple interfaces, I think Scruter will go and do it for you, but I think you have to give it some rules about how it does that. I can't remember off the top of my head the exact details of it. For the date time, how would you call that? So if I can get back to my slides. Let's see where it was. If I've gone past it. But essentially, yeah, I can't find it. Delegates, here we go. So in this one, our delegate is the Kelvin converter mapper. So that's just a signature that says, if you give me a string, I will give you a value. So I'm just wondering if that example is wrong. But basically, you pass in the string, so your CH, that would get a mapper based on the scale. So, oh yeah, that's right. So if you have a look, you've got underscore mapper brackets scale. So that's where we would pass in the string to go and look up which mapper we want. And then I've got the 2 kelvins, which is the method that's exposed on that delegate to go and turn the value into kelvins in this case. Hopefully that answers the question. Is this covered in any more detail in your blog? So I've done a 3-part blog on the disposables. There's a blog post on getting things from name value pairs, and there's the example that I'm using on this delegates here. So those 3 sort of major things are covered on my blog. Are the slides on my blog? No. There's a version of an earlier version, a slightly longer version of this talk on Speaker Deck, and I can try and make that available at some point. For HTTP Client Factory instead, oh yeah, Pete's just posted the link to Steve Gordon's blog in chat. I think that's it, unless anyone else has got anything they need to ask. Anything coming in, Nigel?
Nope, I think everything's is done.
Okay, in which case I'll wrap up. Say thank you for coming and listening to my talk. It's been a great day of talks. So I'm looking forward to catching up on the ones I missed on YouTube. And thank you for your time.